This is the explanation video of CBT, and I'm going to explain question number 4. Question number 4 provides information that is probability of n equal to 0 equals A, and probability of n equals to 0.002745098 times 4 times 5 times 6 up to 3 plus n divided by n factorial times 0.75 power n, where n equals to 1, 2, 3, and onwards. So the question asks us to compute the probability that the number of claims will be at least 8 and compute the expected of n squared given that n greater than 0. So this is my solution. This is what the question gives us, and then it is more easier to solve this question by computing this formula into a negative binomial way. So how to do that? I have to add 1 times 2 times 3 into the formula, and then you divide by the same thing because this is not included in the original formula. And then after that, you 1 times 2 times 3 times 4 times 5 times 6 up to n plus 3 is actually n plus 3 factorial. And then 1 times 2 times 3 is 3 factorial, and then times n factorial. So this is what we get. So this we can convert it into a negative binomial distribution formula, which is this. And then as from this one, we know that k plus n minus 1 equals to n plus 3. So we know that k equals to 4, which is the number of success. And the the probability of success is 0.25, which is 1 minus 0.75. So this is the whole negative binomial distribution. So to get the probability of this, I use the formula negative binomial distribution, and then this is the number of failure, this is the number of success, and this is the probability of success. So when I enter, I'll get the probability, and then I'll put it down to 7, and then I'll get all the answers. So how to find A? A is actually 1 minus the probability of n equal to 1 up to infinity, which is 1 minus the whole this one. So calculate this, and we'll get A equal to 0.30001. So I put it here. Then so how to find the probability of number at least 8? So I use 1 minus the summation of all of this probability. So at the end, I will get the answer 0.501271247. So to compute the expected of n squared, since this is a negative binomial distribution, so I use the negative binomial distribution variance formula to do this. So the variance of n is k times 1 minus p divided by p squared, and k is 4, the 1 minus p is 0.75, and then the p squared is 0.25 squared, and at the end I will get 48. So to find expected of n squared, it is actually variance of n plus the expected of n squared, the whole thing. So at the end I will get the answer 119.1144969. So this is how I do question number 4. Thank you very much.